So yesterday we looked at distance on a graph. We made our right triangle, we counted the sides, we did a squared, b squared, c squared. You are able to do that for any distance problem that you get. Now, unfortunately, not all distance problems end up on a graph. You don't always get the problem on a graph. Sometimes they look like this. Find the distance between 2 points and round to the nearest tenth. And notice these are not on a graph. Now, you've got really two options. One, you could go and get a graph paper out and go and plot these. And if we were in school, that's how I would normally teach you how to deal with every distance problem. However, there's a problem. We're not in school. I don't know if you have graph paper or not. I don't know if you really hate graphing or really like graphing. So I'm showing you a second way to do distance. Both of these ways work for every single distance problem you're going to run into. You could graph all the problems. Now, some of them might be really hard to graph, but you could graph all the problems. Or you could use our distance formula to solve for the distance as well. Now, we're using a formula that looks a little bit scary, a little bit crazy, maybe something a little bit new for you. This is called the equation of a circle, which actually works for distance too. Now, the distance formula is not given to you on the SOL. So instead, I'm going to give you a formula that is on the SOL that works the exact same way. So that way you don't have an extra formula to memorize. You can use this formula right here, this x minus h squared plus y minus k squared equals r squared. It looks real crazy. I'll show you how to use it. It's very simple, and it's going to get you the right answer. Now, one thing you should notice, well, we'll get to that in a second. Let's start here. I've got these 2 points, right? I've got this point and this point. Now, notice each point is made up with an x value and a y value. So this one right here, this would be my x value, that's my y value. Here's an x value, here's a y value. Sorry, that x looks a little like y. All right, so what I'm going to do is I'm going to put my two x values into my x section and my two y values into my y section. So just like this, -6 minus, now notice the minus is already there, and we got a second minus here, minus 9 squared, plus 0, this is my first y value, minus is already there, -4. So notice I just plugged those parts in to my equation. So let's go a step further, -6 minus a -9, that's a big, I know that's kind of a tough one, and we end up with +3. +3 squared plus 0 minus -4. Well, that's going to be 4 squared. So 3 squared plus 4 squared. Notice this looks a lot like a squared, b squared, c squared, doesn't it? And that's because this is straight off a squared, b squared, c squared. So, sorry, let me get the squares there. All right, 3 squared is 9, 4 squared is 16. Is equal to r squared. I get 25 is equal to r squared. And I take the square root of both sides and I get 5. And so 5 would be my answer here. So notice, it's a little more work algebra-wise, but you don't have to graph it. The other way, we'd have to graph these points, counter boxes. So let's go ahead and check that. All right, that looks good. All right, so let's try another problem. Try one more here. All right, this is a really good problem. Let's do this one. All right, so once again, I'm going to plug my two x values in. So I've got 7 minus 4. Now notice, I'm plugging in this x value and that x value. I'm not combining these two together. That's not what we do. We don't combine them inside the parentheses. We take the first one and the first one, and then in the second set, we'll do the second two. So we'll put a squared here, plus 4 minus a -5. Now notice, once again, these minus signs are in my formula. So I'm always going to say minus, and then I'm just going to stick the second number. In this case, I've got -5, so that's why it's minus a -5. So I get 3 squared plus 9 squared. All right, 3 squared plus 9 squared. That's 9 plus 81. We'll add those up, and I get 90. Now, remember, 90 is equal to r squared. My final answer is not 90. If you put 90 in, you're going to end up with the wrong answer. What you need to do is you need to take the square root of 90. So let's go ahead and pull up our calculator. Remember, you can always go to Desmos. That's kind of our calculator, and so I plug it. You can even get it on your phone. You can get the Desmos app if you want. So take the square root of 90, and we get 9.48, and then a bunch of other stuff. Okay. Notice it says round to the nearest tenths. What I'm going to do is I'm going to look at I want the tenths, so I'm going to look back at my hundredths place. That means I'm going to round that up. I'm going to end up at 9.5. All right, and let's check our answer. All right, and that's right. All right, and remember, if you miss the question, it's going to show you how to set it up. It's going to show you how to solve it. It doesn't show you the rounding, and they also show you, look, if you wanted to do it on a graph, if you decide that you have some graph paper, you'd rather do it on a graph, it's going to show you how to do it on a graph as well. And remember, you can always hit show solution if you don't know how to do a problem, and it's not going to penalize you. You just get to look and see how that problem's done. You can kind of copy that. So that wraps up how we cover distance. We did graphing yesterday, we did points today, and hopefully at this point you should feel pretty good about doing distance.